Hi, the 7.5, the Anova table in regression analysis. So in this section, we want to relate the linear regression in chapter 5, chapter 6, and the chapter 7, the analysis of variance. Wow. Yeah. And these two are closely related, actually. So Anova table can be also used to test the significance of predictor in a simple linear regression model. So this is the obvious if the one-way ANOVA have just one factor and only two levels, because the model should be the xij is equal to mu plus the alpha, maybe 2. This is the indicator variable for the 2. So maybe alpha 2 times the indicator variable for the category 2 plus epsilon ij. So exactly that we have one variable, indicator variable for the second group, and we have the two parameters. So we have exactly the same, we have exactly the linear model, simple linear model. So testing alpha 2 is equal to 0 is the same as testing the baseline model, the xij is equal to mu plus epsilon ij against this model. Yeah. So in this way, we can see that whether or not the factor is significant or not. But even this variable is not a predictor and the usual linear regression. So that is xi is equal to mu plus alpha 1, the z, maybe, plus epsilon I. But still, that we can apply the analysis of variance. And if we apply the Anova table for this one, so we have to have some adjustment. So in Anova model, in H1, basically the fitted value for ice group is the group mean of the ice group. So that is the xi bar dot. But here, the fitted value is the mu hat plus the alpha hat times the zi, so zi. So this is usually called the y hat, or maybe in this notation x hat. So we have to replace this estimate by this one. So remember that the sum of squared residuals have the formula includes the xi bar dot, but here that we replace the xi bar dot by the x hat. So in this way that we can apply the Anova table, the theory for Anova table for the simple linear regression. So here is an example. So x is this vector and y is this vector. You can see that the larger x means smaller y probably. And smaller x means the larger y. So we have negative relationship. Okay, so we fit y on x. So we get the y is equal to 18.4 minus 2.1 times x. And we can see the significance of x value by this p value, but also that we can do ANOVA. And okay, so at first, this theory that we have two parameters and we have the 3 degrees of freedom here. So 5 minus 2, number of observation minus 2. So we use the t distribution with df3, then we can get this p value. So how about ANOVA? If we use ANOVA table, that we can get this, and we can get the sum of squared for x and the sum of squared residual. So this is basically SS total, sum of squared deviation total minus the sum of squared deviation for the regression model, our regression model. So SS total minus SS regression. And this is SS regression. Then we can do the so-called F test. So we just divide these numbers by these degrees of freedom, then we can get this the mean square. Then we take the ratio, then we get the 8.23, and we assume that this follows the F distribution with df1 and 3. Then we get this p-value. And actually, this p-value is exactly the same as the previous page. So basically, we do the same thing. So in the last page, that we directly test the coefficient of x, and that we use the T3 distribution. And here, basically, we compare the overall performance of the base model. So xij is, sorry, the yij, y is equal to alpha plus epsilon, and the y is equal to alpha plus beta x plus epsilon. So we compare these two models. So we use the sum of squared residuals. And finally, we get the F statistic. But the F13 is the square of the T distribution, the square of T distribution with df3. So remember that the T distribution is defined by the standard normal divided by the z1 square, z2 square, z3 square, and the take square root and the and the F distribution is basically the z square over the z1 square, z2 square, and z3 square. And actually, that we have to divide the denominator by 3 in either case. But anyway, so this is the square of this. Maybe here again we divide it by 3. So F distribution is the squared T distribution. So exactly we have the same result. So this F value is the square of the T value in the previous page. So this. So this is how Anova table works for linear regression. So Anova is basically the special case of linear regression.